In this video, we are going to see the adjacency list representation of any graph. So let us begin by taking a graph and finding the adjacency list, how to build it up. So let us assume that we have a directed graph. Okay. And the edges are directed. Okay. Suppose here we have the node value as strings, not integer. Okay. So we will consider a very general linked list graph and how to construct its adjacency list. Let us assume that the graph is weighted too. Okay, and the weights are integers 5, 10, 15, and 20. So what we will do is we need to store uh, the value such that it should be a node A, and there should be values stored in the form that A has a h to b comma 5 and to d, and its weight is 20. Similarly for node B, if we write, then it should be b to c and its weight is 10. For node C, if we write, then it is to A and its value is 15, and similarly for D it is nothing. So we have to make this adjacency list. Uh, the the concept is very clear. Okay, now we will look at how to code this. Okay, so let us begin with the code. So adjacency list, what we will do is first we will make class graph, and we will declare in order to make the adjacency list, what we will do is we will use a map of C++ STL. Okay, map, and we will map a string value to a list of pairs of string and int. Okay, so this part is our node, and each pair string comma int is one of these brackets. Okay, so we will be using map of C++ STL in order to store our in order to make our adjacency list. So we declare a map, and it is a string to list of pairs, list of pair, and string comma int. Okay, let us define it as m. Now, okay, we have to make everything public. Now we will write a function to add edge to our graph. Int string x, string y, and bool b. Okay, which is set by default to true, which means our graph is okay. So we will write a function to add edge to our graph, void add edge, and it will contain arguments, the two nodes with edges and their weight, and whether the edge is bidirectional or not. So bool b is equals to false. Okay, false means if this argument is does not given, so we will assume that the graph is not bidirectional. Okay, it has a directed edge. So what we will do is m of x dot pushback make pair y comma w weight. Similarly for the second node. Okay, and we have to add the second node if b means if the graph is bidirectional, then only we will add the edge y to x. Otherwise, we will just leave it adding edge from x to y. Okay, so now we have to write a function to print our adjacency list. Okay, so void print list, and what we will do for we will pick a node to start with. So for auto p in m string current node. Our current node is equals to p dot first, and for auto neighbor in p dot second. See out uh, what the neighbor which gets the value is p dot first is the this node, and p dot second is the list of the pairs. Okay, so while we loop through the list of pairs, each time this nbr will get a pair. So nbr dot first will contain the node, and nbr dot second will contain the weight of that edge. Okay, so what we have done is that we have to loop through our map m, and auto p when it takes all the values. So p dot first, p is this whole, p dot first will contain the node, current node, and p dot second will contain the list of pairs of its edges. Okay, so we loop through that list and print one by one its neighbor and the weight associated with that edge. Now we will go our main function and write the code for initializing our graph. So graph g int n for the number of edges, for int I equals 0, I less than n, I plus plus, int x, y, weight. For this example, let us assume that our graph is a directional one. Okay, so we will leave the bool b value as false because we want a directional graph. See in x, y, and weight. G dot add edge, we will call our method to add the edge and pass the arguments. Sorry, this time the nodes are string and the weight is integer. Okay, and then finally we will print our list. Okay, so it gives error. Okay, I have to change the compiler to C++14 because I'm using the auto keyword, which is not available in with C++ versions less than 14. Yeah, we need a semicolon after a class. And now we can check our code for the input graph, and the number of edges are 4, and A to B, the weight is 5. Okay, so we have some error. Yeah, we didn't input the value of n. That was a silly mistake. For A to B 5, B to C 10, A to C 15, A to D 20, and it prints B to 5 comma C 15 D 20. Okay, B to 5. Okay. Then it prints C 10. Okay, so the output is correct. We need to organize our output. The print statements need to be more explainable, and it should be, first we need to print on which node we are. Okay, so see out current node. Okay, because we need to print the neighbors of a node, so the current node is CURR current node, and then now we are printing the neighbors along with weights. Okay, okay, now it should work. Semicolon. A to B 5, B to C 10, A to C 15, A to D 20. Okay, we get A to B comma 5, C comma 15, D comma 20. Okay, I entered this one. Okay, A to C. So we get and B to C comma. Okay, it is correct for this input. And let me just check again. A to B 5, B to C 10, C to A. Last time I wrote A to C. Okay, that's why we didn't get our expected result. Yeah, and now we can see that what we just derived, the same output we get through our code. A to B comma 520. Okay, so this was for this video. In the next video we will be looking at some of the algos of graph.